So I sent you guys an email saying that this next chapter we're covering is the easiest chapter of the course. So there's going to be no notes on this next test. Okay, so basically there's only three sections: quadric surfaces, first order partial derivatives, and second order, and then we're done. So maybe the test is next week, I'm not sure. Did you guys look at the assignment sheet?
Yes.
I think it is next week. Okay, so let's go back to PCH, see if you guys remember anything. So in two dimensions in the Cartesian plane, what would the graph of this be? So
That would be. Well, what graph? Ellipse.
this.
Ellipse.
Well, it could be an ellipse, but it could be a hyperbola. It could be a parabola.
Oh, yeah.
It could be two parallel lines. It could be two intersecting lines. So what is it? It's a conic section. And remember in PCH, didn't we learn that b squared minus 4ac tells you what it is? If b squared minus 4ac is positive, it's, Sima, 1 out of 3 chance. Huh?
Ellipse.
It's a hyperbola.
Okay, good.
If b squared minus 4ac is negative, it's a ellipse. And if b squared minus 4ac is equal to 0, then it's a parabola. Okay, so in 3 dimensions, we must have the same thing, right? So this is the general second degree equation. Should I even write it out? Because it's written out right there, but that's okay, I'll do it for the people on the video. Ax squared plus, how should I do this? dy squared plus cz squared plus dxy plus exz plus fyz plus g, no, and gx plus hy plus iz plus j equals 0. This is the general second degree equation in 3 dimensions. Did they skip a letter? How come they ended at k? Oh, I forgot the xy term. No, have it there.
They skipped G.
They skipped g?
Yeah.
Why would they skip g? Whatever. Anyway, so any equation written in this form is a quadric surface. That's the title of this thing. So quadric surfaces could be paraboloids. We have different kinds of paraboloids too. We have an elliptic paraboloid, but there's a hyperbolic paraboloid. It could be an ellipsoid, or it could be, what's the other one I never mentioned? Hyperboloid, but then there's 2 kinds of hyperboloids. Hyperboloid of 1 sheet, hyperboloid of 2 sheets. We talked about all of this in PCH, but it's all purged. Anyway, here's the list that they have here. Ellipsoid, hyperboloid of 1 sheet, a hyperboloid of 2 sheets, the quadric cone, elliptic paraboloid, hyperbolic paraboloid, the parabolic cylinder, elliptic cylinder, and hyperbolic cylinder. The last 3 are just, come on, that's just nonsense. Like for example, what is this graph in 3 dimensions? In 2 dimensions, it's simply an ellipse, right? But in 3 dimensions, it's elliptic cylinder. See? Because there's no z here. So in the Cartesian plane, it would look like this, right? But then since there's no z can, no matter what z is, 0, 1, 2, 3, so it comes out like this, right? Call that an elliptic cylinder. See, so that's why those last 3 are just simply easy. Anyway, when you analyze a 3-dimensional graph, there are certain things that we look at. So just like in 2 dimensions, we look at the intercepts. we look at the traces. You guys remember what that is from PCH? When we studied vectors, we went over this. Gone from the memory. Okay, here, they have a list here. Intercepts, traces, the sections, I don't know what that is. The intersections with planes, I don't know about that. The center, duh. Symmetry, duh. And I don't know about that boundness and unboundedness. Yeah. Okay, let's look at an example then. I'm going to erase because we got to stay on this side of the board. What do you guys want to look at? I got it. See, standard form. See how one side is 1? So you can probably guess that this is an ellipsoid. But then when you start putting minus signs in there, I'm going to let you figure out the pattern when you do tonight's homework. So if there's 1 minus sign there, then it's a certain type of hyperboloid. But if there's 2 minus signs, then it's another type of hyperboloid. Okay, so, and then you're supposed to sketch these surfaces too, you know, in tonight's homework. But see, when I make you guys sketch, I'm only going to make you sketch in the first octet because otherwise it's just so difficult. Especially when you're not an artist like me. Are some of you good at drawing? just one person? Okay, so let's look at the intercepts. What is the x-intercept here? Learner. How do you find x-intercept? Set y and z equal to 0, right? So what is it? 4. Plus or minus 4. So there would be an x-intercept over here. But then you would have 1 on the other side. See, if you have to sketch this like this, then you gotta go back and you gotta use dotted lines. It's very difficult. So I'm not gonna make you do that. But just be aware that you're gonna have 1 on the other side as well, yeah? What is the y? What are the y-intercepts? Kanashiro? Plus or minus 3. So same thing, gonna have 1 over here, right? On the other side, but we're not gonna draw that one. And then Simao, z-intercepts?
Plus or minus 2.
Okay, plus or minus 2. So those are the intercepts. Okay, but now we gotta look at the traces. What were traces again? From PCH? What are the traces? Just stay silent. That's where the graph intersects the xy plane, the xz plane, and the yz plane. These are called traces. So how do you figure out what the xz trace is? How do you figure out, no, let's just do the xy trace first. Here, right here. How do you figure out where this graph intersects the xy plane? What do you think I'm going to do? Plug in z equals 0. And you know why that works? Because z equals 0 is the equation of the xy plane, right?
Yes.
Yeah. Okay, so if I plug in 0 for z, you get x squared over 16 plus y squared over 9 equal 1. So that means in the xy plane, you're going to see this ellipse here. So I guess from the top view, it's going to look like this, right? 1, 2, 3, 1, 2, 3. Like that, right? That's where the graph intersects the xy plane, but of course it's 3-dimensional. Okay, but now since we're looking at it at an angle only in the first octet, and again, for those of you who have 3-dimensional problems, it's like you're looking into the corner of a room. See, they're looking into the corner, like that. So the ellipse is going to look like this. It's not a straight line. Don't put a straight line. If it was a plane, then it would be a straight line. Okay, next, what is the xz trace? Where does this graph intersect the xz plane? Well, you could probably guess. Plug in 0 for y. So you're going to get x squared over 16 plus z squared over 4 equal 1, which is an ellipse. So in the XZ plane, you're gonna see an ellipse, which is like this wall right here. So it's gonna be like that. And then finally, the YZ trace. If you substitute 0 for x, you get y squared over 9 plus z squared over 4 equal 1. Hey, that's an ellipse. So in the YZ plane, which is against this wall right here, you're going to see an ellipse. But of course, we're only drawing in the first octant, yeah? And then now you can use your artistic skills. We can shade in. Oh, is that going to work? We'll try it. So you should do it because you're good at drawing. You said you're good. Anyway, that's like the ellipsoid that's in the first octant. So what fraction of the graph is this? This is 1/8 of the graph. Yeah, of course, it extends into the other octant as well. So maybe, I don't know. So when you have to sketch the graph tonight, just do your best. That's all I can tell you. So most of the time, you can look at just the intercepts and the traces, and you can probably figure it out from there. But on some other graphs, you have to look at these other things called level curves. Okay, I'm going to have to erase. Can I erase this now? Oh, by the way, here's the thing. If this is a squared, b squared, and c squared, I believe we also talked about this in PCH, it's going to be an ellipsoid, yeah? What is the volume of this ellipsoid? Knowing what you know from geometry and other things.
ABC minus the sphere.
You had it and then you lost it.
No, it's ABC
Right.
minus
Yeah, okay, there's ABC in it.
There's pi.
Times ABC.
Yeah.
That is correct. You guys understand? We're actually going to prove it because you guys are going to do a triple integral to compute this later on. So what?
Yeah, that's actually the first time. The sphere, right?
Okay, come on. Okay, let's go back to PCH. Why? Because you guys don't remember anything. So when you have an ellipse in 2 dimensions, if this is A and B, isn't the area of the ellipse pi AB? Because if they were equal, you would get a circle and you get pi r squared. So this is like an ellipsoid is kind of just like a flattened sphere, right? So the volume of a sphere is 4/3 pi r cubed, but that's when all the r's are equal, right? But then now, A, B, and C are all different, so it'd be 4/3 pi A, B, C. That would be the volume of an ellipsoid. But actually, like I told you, we're going to actually prove that doing double and triple integrals later on. And by the way, on the last test, I thought you guys were good at integrals. And then I told you guys that that power series 1 was going to be on the test. And we just flubbed it. I think only 1 or 2 people got it, and some people cannot even expand. I wanted to cry. Just go. I want to go home, cook rice. Okay, so let's look at 2 more examples just for. I'm going to erase this. Let's look at an elliptic cone versus a paraboloid. Say what? What did I say? Elliptic cone? I meant quadric cone. All right. So how about x squared plus y squared equal 4z compared to x squared plus y squared equals z squared? Let's compare these two. Wait. Let me think about that. Is that right? You guys don't know. So here, let's just do this one first. Okay, so x, y, z. Okay, what is the x-intercept? Come on, just by inspection. X-intercept. 0. Y-intercept, 0. Z-intercept, 0. See, so that doesn't really help that much, yeah? What about the traces? What is the XY trace? XY trace, song.
X squared plus y squared equals 0.
And what is the graph of that?
It's like,
You give me like last year and they said, oh, it's a circle with radius 0. Huh? It rhymes with anoint.
Yeah, it's pi, right?
What?
Isn't that imaginary number?
I don't know if you can see my face through the glass. What you talking about imaginary? It's kind of like a circle, the center is at 0, 0, but the radius is 0. Just think about it, what's the only numbers you can plug in that's going to make it come out true?
0.
0, 0. It's a point. Oh my goodness. XZ trace. I thought we were going to go home early today. XZ trace.
X squared equals 4.
Which is
Okay.
a parabola. And which, okay, so in the XZ plane, so it's like this. We're not going to draw this. In the XZ plane, which way does this parabola open? Up, down, left, or right?
Right? No, wait, left. Wait. Right.
Is that correct? Okay, just think about it. Which way does y equal x squared open? No, no,
Oh,
no. Y equal x squared.
oh, wait, is Z?
So Z is, you can think of Z as the y-axis, so this is like y equal x squared, right? So it opens up, it's like this. So in the XZ plane, see, but then, see, the orientation is different, yeah? So it's a parabola opening up like this. Oh boy. And then the YZ trace. YZ trace, learner.
y squared equals 4.
So that's a parabola opening upward, yeah? So I don't know. But it's different from that one, so I don't know. See, I'm a bad artist. I can't really. Chen Yi Hu, remember her? She sent me in, the professor did in her multivariable calculus class, he drew this hyperbolic parabola. It was unbelievably beautiful. I should get that picture for you. Tomorrow, I'll go find it in my email. I said, well, oh man, there's no way I can graph it like that. Okay, but see, that, I mean, you can kind of tell what the graph is, but then now, why don't we look at level curves? So what is a level curve? Because sometimes this can help you out as well. A level curve is like, what happens when z is 0? Plug in 0. You get, song, remember? You get a point. What happens when z is 1? Like 1 unit above the xy plane. Plug it in. You get x squared plus y squared equal 1. That's a circle. So 1 unit above the xy plane, you're going to have like a circle like that of radius 1. What about when you plug in 2? Let's plug in 4. No. What did I just say?
Isn't it when
Wait.
Z1's
When we plug in 1 for z, you're going to get x squared plus y squared equal 4. So it's a circle of radius 2 then. Yeah, there you go. Okay, what happens, okay, what's the next number? What happens when we plug in 9/4 for z?
3.
You get a circle of radius 3. What happens when you plug in 4 for z?
4.
Then you get a circle of radius 4. So you can see that these level curves are all circles, right? The radius of the circle getting bigger, but not at a uniform rate. That's why it's a paraboloid as opposed to a cone. Like, I'm hoping that one will come onto a cone. Will it? Oh, by the way, just to see how much you remember, where would the, okay, so this is a parabola, yeah? Opening up. Where would the focus be? Wait, let me call in somebody. Kanashiro. Where is the focus? Let's see if you remember anything from PCH. point?
Oh,
You meant 0, 1.
Yeah.
Yeah, that's correct.
yeah.
Because obviously not, but remember this, x squared equal 4py. P is the distance from the vertex to the focus. Hey, by the way, this is an event for math team, you know, this kind of stuff you gotta know.
That's fine.
So the focus of this paraboloid would be at the point 0, 0, 1. It should be over there somewhere, I suppose. Okay, let's take a look at this one. In fact, you know what? Let's just go straight to the level curves. Okay, what happens when you plug in 0 for z? Hello? You get a point again, the origin, right? What happens when you plug in 1 for z? You get x squared plus y squared equal 1. It's a circle of radius 1, right? What happens when you plug in 2? You get a circle of radius 2. You plug in 3, you get a circle of radius 3, and so forth. So that's why this one is a quadric cone, like this. See, 1, 2, 3, because it's, you know, like this one, it's not linear, you know what I'm talking about? But then now it's linear, so then you get a cone. So that's the difference between the two. So sometimes just looking at the intercepts and traces is not enough. You gotta look at what we call level curves. And that's only because it's changing this way. What if it's going this way? Then you gotta think about, what if y equals 0, y equal 1, y equal 2, and y equal 3? So there's all of these things to think about. Look, sun's falling asleep already. So what you have to, let's bring up the homework for tonight. So you guys know what to do. My McDonald's lunch is getting cold already. Okay, so we're only gonna do the starred problems. Did I send an email about that? How come Simao is nodding and these two clowns here are going, what? What email? And why is Park having to check his email? If I sent you an email, you would know it, right, Hong? So did I send an email that said we're going to do the starred problems? See, I tell you. You guys cannot even read an email. Okay, so here are the starred problems. Only do those, and the answers are on the bottom. Okay, so what they're going to give you a surface, and then you just identify it. Look how easy this is. Look, number 1. Just look at it. You don't even have to look at any notes because we just talked about it 2 minutes ago. Doesn't that kind of look like the thing we just talked about right there? Okay, you know what? You guys figure this out on your own then.
You didn't send an email. They were lying.
It was the chapter one though.
Then why is Simone saying yes?
I saw it somewhere. Maybe it wasn't an email. Maybe it was like a. I thought it was.
Oh, maybe I mentioned it somewhere.
I don't
Oh,
think so.
yeah.
Okay, it doesn't matter. Okay, we're gonna make an official announcement. You guys watching the video, on tonight's homework, you only do the starred problems, because that's the only one I give you answers to, so just do those. So
I thought it was this one.
so the first bunch is you just have to identify. So on the next test, which is, I think it's next week already, the first page is, I'm gonna just give you an equation, you just identify it. That's why, I'm not gonna give you notes, right? If you don't know what it is, then plot intercepts and traces and look at the level curves and figure it out. Okay, but then there's some really interesting problems here. So like there's 3 problems where you actually gotta sketch the surface. But the last 3 problems are kind of interesting. Okay, why don't I read it then? Write an equation for the surface by revolving a parabola about an axis. So you end up with a paraboloid, and then you have to write the equation of that. That's the kind of problems you're going to see on the test. Or 28. Determine where a sphere intersects a hyperboloid. Basically, you just combine the equations just like you do in Algebra 2, right? And then number 30, the parabolic cylinder intersects the elliptic paraboloid in a curve. What is the projection of that curve onto the xy plane? That's super important, because that's how you figure out your limits of integration when you do triple integrals. Mr. Park, I can barely do single integrals. You're correct about that. Okay, so any questions on this? This is easy, and you know what? The next two lessons are going to be even easier. We're going to compute partial derivatives. I can barely do regular derivatives. Questions?
I figured out where it says in the assignment sheet, I was looking at it, and it says quadratic surfaces start up.
Oh, there you go. So that means the 5 of you that are originally in this class didn't look at the assignment sheet. No sense even it's all in Kanashiro already. Hey, you guys better start paying attention. That's right, Dole. I'm talking to you. All right, let's turn off this monstrosity here.